This is GCSE Physics past paper question 7, and past paper question 7 is on motion. Juno 7 paper 2, question 1. The diagram below shows a hovercraft of mass 8 tonnes. So the first thing you notice there is the 8 tonnes. The hovercraft is stationary and is floating on a cushion of air at a constant height above the surface of the sea. Calculate the weight of the hovercraft. Take 1 tonne as 1,000 kilograms. So the first thing you're going to do there is calculate weight. Now, weight and mass are different and they're connected by the equation weight equals mass times acceleration due to gravity, W equals mg. So the mass is 8 tonnes. But whenever we use this equation, that has to be in kilograms. So you have to multiply it by 1,000. So it's 8,000 kilograms. So the weight is going to be 8,000 multiplied by, the value for G on the earth is 10. And the examiners expect you to know that and to use that value. So it's 8,000 times 10. And that gives you 80,000. So be careful with the knots and make sure you don't lose any. 1, 2, 3, 4, 1, 2, 3, 4. And the answer is 8,000 newtons. Sorry, 80,000 newtons. Almost made the mistake myself there. So there's 1 mark for your answer. And there's 1 mark. If you just wrote down W equals mg, you would get a mark for that. What can you say about the sizes of the weight and the upward force on the hovercraft? Explain your answer. Now, this is about balance forces. The hovercraft isn't moving up or it isn't moving down. So that means that the weight and the upward force are equal to each other. So we're going to say that weight is equal to upward force and the reason is because there's no and I'm going to use the word vertical, which is up or down, but if you wrote up or down, that would be absolutely fine. Vertical motion. And that gets you 1 mark there and 1 mark there. When the thrust from the hovercraft's engines increases to 2,000 newtons, the hovercraft moves forward at a constant speed of 2 meters per second. Now, they've got constant speed in black there. So the first thing, there's quite a lot in this question and it's worth 5 marks. And most people don't get this kind of question right. It is an F equals ma question or Newton's second law question. But the first bit of information you're being told there, when the thrust from the hovercraft engines increases to 2,000, so if this was 2,000, then the hovercraft moves forward at a constant speed. So that means there must be balance forces acting on it in that direction, constant speed. And constant speed means that there's 2,000 newtons of resistance or friction acting backwards. So it now says the forward thrust from the engines is now increased to 3,600. So I'm just going to put a line through that. It's now not moving with this thrust, it's moving with 3,600 newtons. So it's 3,600 newtons to the left and 2,000 to the right. So assuming the size of the other forces in the hovercraft are unchanged, i.e. that this 2,000 doesn't change, show clearly that the acceleration of the hovercraft is 0.2. Now we're not one bit concerned about either of these two. They're equal to each other and they're not having any effect on the forward motion in this direction. So the first thing we're going to do is find the resultant force. So 3,600 to the left, take away 2,000 to the right, and that gives you a total of 1,600 newtons. And then we're going to use F equals ma, so F is equal to ma. And the F that we use is that resultant force, 1,600 newtons. And that's equal to the mass, which we are told way back at the beginning of the first question, the mass is 8,000 kilograms or 8 tonnes multiplied by A. And A comes out as 0.2 meters per second squared. And that's the answer. So 1 mark for this, 2 marks for this part here. 1 mark for recognising that the friction is still 2000, and 1 mark for F equals ma. The next part of the question, in practice when the thrust is 3600, the acceleration is actually less than this value calculated here. What happens to the forces opposing the motion as the forward speed of the hovercraft increases? So that means that in this calculation, this 2000 must be bigger. Even though it's the thrust of 3600, this must be bigger. So that means that the forces opposing the motion must increase. Tick the appropriate boxes in the table below to show the quantities which have direction and those which do not. So this is a scalar and vector question, and quantities which have direction and quantities which don't. So the first one's distance. Distance has no direction, so it's in there. Velocity has direction, displacement has direction, and speed has no direction. So we've got 2 scalars and 2 vectors, and there's half a mark each. And even if you only got 3 of those right, I'm afraid you'd only get 1 mark. They round down in this question.